That has not hold it against me. Okay. So number 1, we have 6x plus 3y equals 51. 2x subtract 6y equals 38. So we want to get the y's to look the same since they have these different signs right here. So I would need this one to be 6y. So when I add my equations, it'll cancel out the y's. So we're going to multiply the top equation by 2. So we'd have 12x plus 6y equals 102. This one, just bring it over. 2x subtract 6y equals 38. Also on this test, you're going to use a whole page of notes, not a note card. Add equations. So we have 14x equals 140. Divide by 14. X equals 10. Then we're going to take this and substitute it into one of the equations. It doesn't matter which one. I'm going to write down here sub into equation. I'm going to use this one because I don't want to divide by a negative. So we'd have, I'm just going to write it under 6x plus 3y equals 51. So we'd have 6 times 10 plus 3y equals 51. 60 plus 3y equals 51. Subtract our 60. 3y equals negative 9. Divide by 3. Y equals negative 3. So we have x equals 10 and y equals negative 3. X equals 10, y equals negative 3. It's always just end up being on one side of the page. Are we good, or do y'all need that still? Okay. I could more. All right, 2, we have x plus y equals negative 5, and x subtract y equals 13. Does anyone have theirs on, and can you hear them? Okay, so then we'd add our equations because their y's are already the same. X equals I'm going to use plus 5 equals negative 5. And so we have 4 plus y equals negative 5. Subtract my 4. Y equals negative 9. So x equals 4 and y equals negative 9. Sure y'all can spell that. So x equals 4. Y is negative 9. I'm going to go ahead and write 3 down. So we have 5x subtract 2y equals negative 1, and then x plus 4y equals 35. So signs are different right here. So I'm going to multiply the top equation by 2, so that it'll be 4y as well. So then we have 10x subtract 4y equals -2. This one goes over, so we have x plus 4y equals 35. So that would give us 11x equals 33. Divide by 11. X equals 3. So we're going to substitute this into one of those equations. This one. So into x plus 4y equals 35. Right here, so I have room. So we have 3 plus 4y equals 35. Subtract 30. 4y equals 32. 32 divided by 4 is 8. Right? So we have x equals 3 and y equals 8. Which is A on that one. Number 4. We have x squared plus y squared equals 4. X squared subtract y squared equals 4. So since it's positive y squared subtract y squared, we're going to add our equations. Because x squared plus y squared would be 2x squared, y squared subtract y squared, or plus a negative y squared is 0. So it equals 8 divided by 2. X squared equals 4. Remember on this, we take the square root of both sides. We have the square root of x squared equals the square root of 4. This is going to give us the positive and -2. Don't forget them. Don't forget the negative. Everybody gets negative. So x equals positive and -2. Then we'd have to take both of them and sub them into it. Let us see our options are right now. So +2, -2, +2, -2, -2, -2, +2, +2. So positive and -2, they're not both the same. Okay. And let's sub them into the top one. So sub into x squared plus y squared equals 4. So I have 2 squared plus y squared equals 4, and -2 squared plus y squared equals 4. 4 plus y squared equals 4. Subtract 4. Y squared equals 0. Square root of 0 is still 0. When we square our negatives to the positive, negative times negative, so we have 4 plus y squared equals 4. We do the same thing over here. So y equals 0. So our answer would be 2, 0, and -2, 0. The other option had 2 as the y value. Okay, let's do 5. So we have y equals x squared, subtract 3. X squared plus y squared equals 5. Since it's solved for y and y is not squared, we're going to have to substitute that x squared, subtract 3 in for y squared. So we have x squared plus x squared subtract 3 squared. So we took all of this and substituted it for y. I'm going to write this right here. Over here. Because it ended up with x to the fourth subtract 3x squared subtract 3x squared plus 9. X to the fourth subtract 6x squared plus 9. Then I'm going to put it back up. So x squared plus x to the fourth subtract 6x squared plus 9 equals 5. And for my 5 over, that's 0. And I'm going to put them in order right now. So I do my x to the fourth first. Subtract 5x squared. I subtract 5 would be 4, so I'm trying, yeah. Where? This. So I try, did I get this? Oh, I put them in order. So x to the fourth goes first. Then this is x squared and this negative 6x squared. So yeah. I'm trying to decide where to tell y'all this part. I keep working it out and I will regardless. But right now, what I want you to notice is this is x to the fourth, which we could figure that out right here. There's 4 x's. Okay. There's going to be 4 x's as your answer. There's only one that has 4 x's as your answer. And I can work it out the rest of the way, and I'm going to work it out the rest of the way. But once you see that it's x to the fourth, there's 4 x's with, because you can use your deductive reasoning skills and say, actually, one of these, that have 4 answers. Okay. So if we factor this out, we have to factor using substitution, like x is squared. So when we do it, we have x squared subtract 4 times x squared subtract 1. Both of these are the difference of 2 squares. So the square root of 4 is 2. So x subtract 2 times x plus 2, because these two are this factor. And if you multiplied it out, it would be the same. And then right here, there's a square root of 1. They always get you with the 1. X subtract 1 times x plus 1 equals 0. So that are 4 x's. We have 2, negative 2, 1, negative as x's. And then you would have to substitute every one of these into an equation to get the y values for it. So you'd sub into, I'm going to do the one that's already y equals. So if I do x equals 2, I have y equals 2 squared, subtract 3, 4 subtract 3, so y equals 1. So I have the point 2. But if x equals negative 2, we have y equals negative 2 squared, subtract 3, which would be 4 subtract 3 is 1. So we'd have negative 2, 1. Then we'd have x equals 1, so y equals 1 squared, subtract 3, which would be 1 subtract 3, which equals negative 2. So we have 1, negative 2. X equals negative 1, so we'd have y equals negative 1 squared, subtract 3, which would be 1 subtract 3, which gives us negative 2, which is negative 1, 2. And all 4 of those would be our answer. There's only one is 4. Another way to look at this would be We know that this x squared subtract 3 is that parabola that's moved down 3. X squared plus y squared is a circle with a radius of the square root of 5. So it's a circle that's being intersected by a parabola. It's not going to change that it's the only one that has 4 answers. We're going to do the first 5 rows. So 6 is y equals x plus 3. And then we have y squared equals 12x. Since this one's y equals, we're going to substitute it in for y squared right here. So we'd have x plus 3 squared equals 12x. So we have x squared plus 3x plus 3x plus 9 equals 12x. And I just squared that. Yeah. Okay. So x squared plus 6x plus 9 equals 12x. Move my 12x over so that this equals 0. So x squared subtract 6x plus 9 equals 0. If we factor this, it's going to be one of those perfect ones, and it's going to be the same thing. Factors 9 that add to get 6 would be 3 and 3. And then since this first sign subtract, it'd be x subtract 3. It's x subtract 3. So they're both the same. We're going to end up with just x equals 3. Then we'd substitute this into whatever equation is easier. Y equals x plus 3. So y equals 3 plus 3. Y equals 6. Our answer would be 36. So on this one, there's only one that has one x value, so you could have stopped when you realized they were the same. All right, 7 and 8, they give us the zeros and the degree. So this is from 5.1 where we had to multiply. This one has the degree of 4. Thing to do this. So our zeros are -3, -4, and 4, and then they tell us the degree is 30. So on this one, you're going to have to use that subtract r, where your zeros the r. So when we substitute these in, I put x subtract -3, x subtract -4, and x subtract 4. So we have x plus 3 times x plus 4 times x subtract 4. And just multiply all of that. And be sure you get your signs in order, because on this, the only changes, they all have x cubed at the beginning. They all have 48, they all have 16, and they all have 30. It's going to be your signs. You have to watch your signs. And also pay attention on this one. And it hurt me. They did this. It goes x and x squared. They didn't put them in order by their powers. So they didn't write it in standard form. But, yep. Okay. So we'd have x squared plus 4x plus 3x plus 12. We still have to multiply by this. Combine terms, x squared plus 7x plus 12 times x subtract 4. So we have x cubed, subtract 4x squared plus 7x squared, subtract 28x plus 12x, subtract 3, combine terms, x cubed plus 3x squared, subtract 16x, subtract 48. And if I want to put it how they put it, because they don't do it right, x cubed subtract 16x plus 3x squared, subtract 8, and that'll help me map my lines. So we have x cubed subtract 16x, so it's not this one, this one. And then plus 3x squared, so. All right, the next one's 4. So we have our zeros are -4, -1, 3, 5, 3 is 4. And we're substituting them into this x subtract r again. So we'd have x subtract -4, x subtract -1, x subtract 3, and x subtract 5. So we'd have x plus 4 times x plus 1 times x subtract 3 times x subtract 5. So x squared plus x plus 4x plus 4. I'm going to go ahead and do this set too. X squared subtract 5x subtract 3x plus 15. Combine my like terms. X squared plus 5x plus 4. X squared is 8x plus 15. So we have x to the 4th subtract 8x cubed plus 15x squared plus 5x cubed subtract 40x squared plus 15 times 5 would be 7. Plus 4x squared subtract 32x plus 60. All right, x to the 4th is first. Cubed. -8 plus 5 would be -3x cubed squared. So that would be -40 plus 19. So subtract 21x squared. 75 subtract 32. What do I have over there? 43x plus 6. X to the 4th subtract this. This doesn't have an x cubed. Subtract 21x squared, same, plus 43x plus 60. So, you just look at this solid failure. Okay, on 9, the polynomial is each real 0 and its multiplicity. Determine whether the graph crosses or touches at the x-axis at the intercept. So x subtract r, and the multiplicity is what's on the top. So r is the 0, m is the multiplicity, even multiplicity touches odd multiplicity crosses. So this is plus 1/5, that means it would be negative 1/5. You should know that from the last part now. So B and C aren't options. Then we have 2 as our multiplicity here. This one says touches, this one says crosses. Evens touch, odds cross. So I guess you could really just check the multiplicity on these. So this one, the multiplicity is 3. They have cross here, they have touch here. But in same thing, since it's positive 1/3, that we have our 0 to negative 1/3, multiplicity is 2, so it touches. So negative 1/3, multiplicity 2 touches, negative 1/3, multiplicity 2 touches, crosses. And this one has a positive 1/3. This isn't a 0. Because there's nothing that we could put in for x squared that would make it 0. Like if we wrote it out over here, x squared plus 4 equals 0, and we subtract this 4, x squared equals a negative 4. X squared is ever equal to negative, that's not a. So it's undefined, there's no solution, it's not a 0. So the answer is A. Because the whole thing with something being a 0 is you can make equal to 0, we can't make that equal to 0, so it's not one. But on the bottom of this function, what would make the bottom be 0? We have x plus 4 equals 0, and x subtract 4, 0. We're doing domain, we only care about the bottom because the 0 is on the bottom, it's undefined, and it can't be part of the thing. Asymptotes. So this one is x equals negative 4. This one's x equals positive 4. Those are our asymptotes. That is what the domain cannot equal. What the crap? This is right, but this one's also right. They just wrote them in a different order. So I'll just make them because this one's negative 4, 4, and this one's 4, negative. So if you mark either, then you'll get right. I'll just have to take it trading. Oh wait, this goes back to that part we just had. It's the same thing. The domain. If we have x squared 0, that's not equal 0. So we subtract our 1. We have x squared equals negative. This cannot equal a negative, so there's no solution. So it's all real numbers. There's nothing that would make the bottom of that be 0, so there's nothing that can. But on this right here, this 13 and 14, 14 is 30. They're asking only about vertical asymptotes. So this one is easy. Just remember vertical asymptotes are x equals. So x equals, and the x value here is negative 4. Here, they're only asking about vertical asymptotes, so don't mess up horizontal. So we only care about x equals, and we have 2 and negative 2. So this one right here, y equals 1. That's a horizontal asymptote. It's not wrong. I'm probably going to give you credit if I see that happen. But this is technically the right answer. So vertical asymptotes are x equals. The next question is going to be horizontal asymptotes, and that's going to be y equals. Use graph to find horizontal asymptote if any of the function. The horizontal is y equals our y value is 3. We have an oblique. So do 1 to 1 right here. You have to find slope because when you do your oblique asymptote, they want it in the form y equals mx plus b. So we need our y-intercept. So our y-intercept is 0, our slope. This point would be an asymptote, which is 1 to 1. So our slope is 1. So we have y equals 1x plus 0, or y equals x. Remember, if it's going this way, it'd be a negative slope, because I think one of them has a negative slope. Y-intercept of f of x, when you're doing y-intercept, you put x as 0. So we have y equals 0 subtract 5 over 3 times 0 subtract 2, which would be negative 5 over negative 2, or 5 over 2. Find the domain of the rational function. I like this one got separated from its friends that was earlier on. So it would make the bottom of this be 0. So x equals 6. This is an asymptote, which means the domain x cannot equal 6. But 17 is the one I substituted for instead of this one. The answer to this one, if y'all have it though, we're going to ignore that. So right here, when you photograph this one, you're going to need to find, you're going to factor this. So we factor the top, factors of that multiply to get 12 and subtract to get 1 with 3. This is a plus sign here. We have a positive 4 and a negative 3. So I have x plus 4 over x subtract 3. Here, factors of 20. That's to get 1 would be 4 and 5. Since there's a subtract here, the log always gets that sign. So I'd have x plus 4, x subtract 5. Since these two are the same, we get it lowest term by canceling out. So what we're actually graphing is x subtract 3, x subtract 5. So we go to find our domain for this one, that x subtract 5. We know we have a vertical asymptote. At x equals 5. We also know that the x-intercept is x equals 3. So looking at these both have 2 vertical asymptotes. Those are wrong. Looking at these 2, I have this one is at x equals 5. This Let x equals I said I didn't need the intercept. I need to know if it's positive or negative. Both have the same intercept at x equals 3. What we need to know if our graph is positive or negative. Is there a negative in front of any of this? So our graph is positive, which means it's going to be above the x-axis at the end. So this one would be a negative graph because it's below. And this is our positive. This one is way easier than the one that I had to worry about and be cast and hope. We need to focus on that. So now should I just want to prove that was? Oh, I know both. But here we check out this bottom, so we have x over x subtract 1 times x plus 1. So our vertical asymptotes are x equals 1 and x equals -1. Why didn't I get rid of this problem? Did this forever yesterday, and I figured out the difference between graph A and graph C because there's not a difference. So this one's not because it doesn't have vertical asymptotes at one. These all do. Then we check if our graph is positive, negative. So it's positive because there's not a negative in front of it. So we have a positive, which means it will be above the x-axis at the end of the graph, or a positive side. And so this one goes away, and these two are the same graph. There's nothing different with them, and I stared at them for a good long time. We don't have that. One of them. Of the last five are solving inequalities, which means those intervals. So 21. We have x plus 6 times x plus 4 is greater than 0. So our 0 here would be -6, and our 0 here would be positive 4. And then when we set our intervals, so find zeros, set intervals, select test numbers, test. I'm not write that down somewhere in a minute. I don't have time. So we have negative infinity to -6, -6 to 4, and 4 to infinity. And you have to test numbers. And then you have to test. So we want it to be greater than 0. So I have a -10 plus 6. -10 subtract 4 is greater than 0. So this would be -4 times -14. -4 times -14 would be a positive, which is greater than 0. So this is an answer. Circle it. And then, so -50 to -6. No, it's not these two. So then all I have to do is check that. So we have 5 plus 6 times 5 subtract 4 greater than 0. This would be 11 times 1. 11 is greater than 0, so 4 to infinity is the answer. 22. We have x squared plus 7x is equal to 0. So first we factor this by factoring out 7. So then we have x equals 0 and x equals -7. Set your intervals to infinity to -7, -7 to 0, and 0 to test numbers, -10, -1. So then we sub them in. So let's do -10 times -10 plus 7 is less than or equal to 0. We have -10 times -3 less than or equal to 0. No, because it's positive. So that's not in the answer. So we have -1 plus 7, -1 times 6. -6 is less than or equal to 0. True. So this is in the answer set. I'll squish these together. Not really. I know. So I know infinity to -7 is not. That wasn't even an interval option. I know -7 to 0 is though. And if I check this, we'd have 1 squared plus 7 is 1, which is all positive. So that's not less than or equal to 0. So remember on this one, 23, it's that fraction and it's stacked. We have x equals -8 and x as our zeros. Because this is where x is up and this is the domain cannot be. I should have wrote that this out. So we set our intervals. We have -infinity to -8, -8 to 5, and 5 to infinity. So -10, 0, and +10. -10 subtract 5 over -10 plus 8 would be -15 or -2, which is a positive number, which is not less than 0. So this one's no. 0 subtract 5 over 0 plus 8 would be -5 over 8, which is less than 0. Negative is less than 0, so true. So this is in the answer set. There's only one has that. Can't see that. I took 24 out. I can't remember what I substituted it for, but I didn't want y'all to have to deal with finding the common denominator and putting it all in. So we're going to skip that. I mean, one that wasn't, there's not a number over there. So sorry. And I uploaded it on Blackboard, but there's 2 ones on there. The most recent one is the slider test. So let's do 25. So x to the 4th is less than 64x squared. We move our 64x squared over to x to the 4th. We would factor out x squared. So we have x squared subtract 64 is less than 0. This is the difference of 2 squares. So we have x squared times x subtract 8 plus x plus 8 is less than 0. So x equals 0, x equals 8, x equals -8. And we would set our intervals with that. So got -infinity to -8, -8 to 0, 0 to 8, and 8 to infinity as numbers, -1, 10. Since these match up, since we're dealing with squares and cubes or powers, you really only need to work out these two, and these will match their counterparts. So we'd have -10 squared, it's -10 squared, subtract 64 is less than 0. 100 times 100 subtract 64 less than 0, that'd be 3,600, so that's not less than 0. But if we do -1 squared times -1 squared subtract 64, we would have 1 times 1 subtract 64, which would be a -63, which is less than 0, which is true. And when we square these right here, it'd be the same as 1 squared because our negative goes away, which is positive. So these two are answered.